Hi there. This video is about loudness, the decibel scale, and sound intensity and intensity level. So we've got different ideas here, and we're going to start with the idea of intensity. And you already have a good sense of the intensity of something. Intensity it's the power over the area. That's the basic level, and you're like, okay, what does that mean? So let's say you have a 100-watt light bulb. That's our power. And area. Okay, so if I have a 100-watt light bulb right here, and I'm really close to it, it's pretty bright, the intensity is pretty big. That's because that 100 watts is shining over a sphere about that big. If I'm way out here, that 100 watts is now shining over a sphere, an area, oh, that's not really circular, but hey. Now that 100 watts is spread out over this much area. It's much less intense. And you know that it's less bright when you're farther away. So the idea of intensity is power, the source, how much power the source has over the area that power is spread out over. And it's not just like light bulbs, it's also sound waves. So we can do something similar when we're talking about sound. Now, if you have ever looked at a speaker, you may have noticed that speakers are often rated in watts. That is the power. And so if you know the number of watts a power gives, and you know how far away you are, which is kind of hiding in this area, you can actually figure out the intensity of sound that is being produced at that certain point, here or here, you know. And just like with light, if you're this close to a speaker, it's a lot louder, its intensity is a lot bigger than when you're this far away. So when we're talking about hearing, we're going to be talking about intensity and about loudness. And loudness it's an interesting thing. Our range of hearing is huge. And the intensity that we can hear, the sound intensities that we can hear, the smallest thing that we can hear, the smallest sound that we can hear, I guess, has an intensity of 1 × 10 to the minus 12 watts per meter squared. Now that is tiny. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's tiny. So we can hear a noise at that intensity level. And that's the lowest end. This is what we call our threshold of hearing. We can also hear things that go up to 1 watt per meter squared. And so we have a factor of, what is it? That's 1 trillion. So we can hear sounds this small, or we can hear sounds 1 trillion times bigger. That's a huge range. That's a really big range. So what we do is mathematically, we use one of the tools that's really good for dealing with large ranges of numbers. And that is the logarithm. So don't freak out. I'll help you through it. You don't have to go back to, oh my gosh, what class was that? And I don't remember anything about this. So yeah, we're all good. So we use the logarithm to help us deal with ranges like this, where we have such a large range, there's no good way to think about it even. I mean, what's the, how much bigger is 1 than 0.00001? So what logarithms help us do is they convert these really huge or really small numbers into reasonable numbers. And it does that by looking at factors of 10. So a logarithm looks at factors of 10. It's the tens. So an example would be that if we start with an intensity of 10 to the minus 12 watts per meter squared, that's our threshold of hearing. That's the smallest sound we can hear, we can sense. And so we're going to call that a level 0 of loudness. And what we do is with the logarithm, every time we go up by a factor of 10, we go up by actually 10 here. And so if I go from negative 12 to negative 11, that's a set of 10. If I go up from negative 12 to negative 10, so I'm dropping zeros each time, this would be 20. And 9 would be 30. So if I jump down to negative 5, 70, I'm going to double check that. I want to make sure I get that one right. Yeah. 10 to the minus 4 would be 80. 10 to the minus 3, 10 to the minus 2, 10 to the minus 1, and 1. Okay, so this would be 90, this would be 100, this would be 110, and 120. And so what these numbers are, they're really just saying how many tens do I have different. So every factor of 10 I go different here, I add 10 here. So what's the difference from 12 to 3? So 12 to 3, that's 9 tens, 90. Okay, so from 5 to 1. 5 to 1 is a difference of 4, so that difference would be, 40. Yep. So that's what this is. And this right here, this is the loudness scale. So here is what we consider loudness, and the unit you're probably familiar with. It is decibels, which we give little d, big B. So there's a connection between intensity and the loudness, which we also call intensity level. Intensity is power over area, and then the intensity level, which is given the Greek symbol beta, has this ugly looking formula, but it's not that scary. Really, it isn't. So beta is 10 times the log, and the logarithm is kind of this weird factors of 10 thing, times the intensity, which we get from here, over I naught. And I naught is that lowest threshold of what we can hear. It's, I'm not sure where I was going there, 10 to the minus 12 watts per meter squared. So let's just get rid of that. I didn't do that. So this number right here, this is I naught. That's the lowest intensity sound we can sense. And that matches with 0 decibels, so lowest level of hearing. And then we can go up in decibels as our intensity gets bigger. So what do these represent really? So what is 30 decibels? What is 60 decibels? What is 120? So here, this is a quick scale of sounds and their decibel levels. So a classroom, a jet engine, a rock concert. So there's some examples of what different sounds have for typical decibel levels. So what we can do next is kind of play around with this. And using this information, we can actually see some interesting patterns. I'll call them patterns. All right. So when we're talking about the area, I said it was kind of a sphere, you know, like the light bulb is, the intensity of the light is over an area. We're talking about the surface area of a sphere. And so when we're talking about that, this becomes the surface area of a sphere, which is 4 pi r squared. I don't expect you to remember that, but it'll be useful for us to do some practice. So let's say we have a speaker that's labeled for 3 watts. Totally reasonable speaker. So our power is 3 watts, and we're standing 0.75 meters away, 75 centimeters away. So that's, 75 centimeters, something like that. That's 0.75, 75 centimeters. Let's figure out what the intensity is, and then we can figure out what the intensity level, the loudness is. So intensity is going to be power over area. Well, the power is 3 over the area, which I said is 4 pi times distance squared. 4 pi times 0.75 squared. And if you do the math, what do you get? 0.424 watts per meter squared. All right, so what would the loudness be? Well, if I look at this, 0.4, what is that in, where is that in this range? Well, 10 to the minus 1, that's 0.1. This is 0.01. This is 0.001. So 0.4 would be between here and here. So our intensity is in between here. So I would expect my sound, oh wait, nope, I just did that wrong. There, our intensity is between 0.1 and 1. So between 0.1 and 1, so 0.4. It's like not quite half, just short of half. So I'd expect my intensity, my sound level, intensity level, sound level, loudness, to be between 110 and 120. So if you do this number, if you do this calculation, don't worry about it. You don't have to do that for this class. What you actually get is the intensity level, the sound level is 116.3 decibels. Yeah, right where we'd expect it. So we've got this loudness of 116.3 decibels. Now, what should happen if I increase the power to 30 watts? And that's unreasonably loud. So let's think this through. If I increase the power to 30 watts, that's going to put, this top number is going to be 10 times as big, which means the whole thing will be 10 times as big. So my intensity is going to become 4.24, 10 times as big. Move it one decimal bump over. And so now we're at 4.24. Okay, we're up over this range. Not good. Our ears are going to be hurting and damaged if we had something this loud. So what is our range now? Well, 4 is between 1 and 10. So if I had 10 here, that would be 130. So if I'm between 1 and 10, now it should be 120 to 130. And if we calculate it, we get 126.3 decibels. So take a look at these two numbers, 116.3, 126.3. They're off by a factor of 10. Wait a minute, that's what we multiplied our power by. That was the difference in the intensity. This is what this logarithmic scale is doing. If we change this by a factor of 10, this goes up by 10, just straight up 10. So what we're doing is every time this changes by a factor of 10, we add 10 decibels. So if I were to switch my power to 3,000 watts, okay, so 30, so now I'm making it 100 times bigger, my intensity would go to 100 times bigger, 424. These are ludicrous numbers, not realistic. And we don't have to do the calculation for the intensity level. We can just say, okay, well, okay, if it goes up a factor of 10, I increase by 10, but it goes up another factor of 10, so I'm going to increase by 20, so my final loudness would be 146.3 decibels. So I hope this has given you just a rough sense of how the logarithmic scale works. It's all about the number of tens. Okay, so here's another example using this idea of the logarithms. Let's say we have a stadium. Okay, I don't know how to draw a stadium. It's a big thing. It's round and it's got all these people in it. There, all these people in it. Let's say there's 10,000 people in the stadium. All right, and they are each, well, let's just say that the total intensity level, the total loudness, it's going to be pretty big. Let's put it at 130 decibels. Now, what would we have for the loudness of one person? How loud is one person yelling if 10,000 people yelling add up to 130 decibels? So what can we do? So we're going to go from 10,000 to 1. How many tens are we dropping by? Well, we're dropping by 1, 2, 3. We're going down by 4 sets of 10. 4 times 10s. And so what that means is we are going to drop by 4 times 10 decibels. We're going to drop by 40 decibels, which means that one person is yelling at 130 minus 40. That gives me 90 decibels. It's totally unreasonable. But hey, we're just calling it an example. It doesn't have to be reasonable, right? So you're just counting up the number of zeros that you're changing it by, and that is going to give you, that times 10 is going to give you the number of decibels. So for every factor of 10 that we change the intensity, we are going to drop our loudness by that number of decibels. All right, so there's one example. The other piece that's really interesting about loudness, well, okay, let's think about it. If I have one person talking at 50 decibels, and then we add another person talking at 50 decibels, so that's, you know, normal talking conversation. Does that mean together they are producing 100 decibels? Like, you know, up towards a loud freeway? No, two people talking is not the same loudness as a loud freeway. So we can't add decibels. This is the weird thing about a logarithmic scale. You can't add them directly. And if you think about it, yeah, 50 plus 50 is not going to be 100 decibels. That doesn't make any sense. If you do the math, what turns out is that if you times 2 in the intensity, so if you double the number of people, that means you only add 3 decibels. Again, this is that weird logarithmic thing. So every time you double the intensity, you add 3 decibels. So if I have one violin that's playing at 62 decibels, 2 violins, then, okay, double it, I'm just going to add 3. That's going to be at 65 decibels. 4 violins would be at 68 decibels, and double it again. 8 would get you 71. 16 violins would get you 74 decibels. And so every time you double the intensity, like double the number of people or speakers or whatever's making that sound, if you double that, then you can add 3 decibels, but only if they're all playing at the same loudness. So if I had one violin at 62 decibels and another violin at a little bit quieter 60 decibels, it wouldn't be 65, it would be less than that. But one of the things I'd like you to keep in mind is that if you double the intensity, all you're doing is adding 3 decibels. That's another weirdness about logarithms. Let's see if I've got anything else I wanted to do. Yeah, another example. So many of us, and all of us should have ear protection for various things. Many of us use ear protection for when we're doing loud power tools, or we're in a loud area. You know, the construction on campus that you see, those folks are all wearing hearing protection. So if we have, let's say, you have headphones that are, they say, if you look at your ear protection, your hearing protection, it should say, will reduce sound by this many decibels. So let's say you have headphones that claim they can drop the loudness of the sound by 40 decibels. What's the actual intensity going down by? This is the loudness. So what's the intensity going down by? All right, so every 10 decibels means a times 10 difference in intensity. So if I go down by 10 decibels, that means intensity goes down by times 10. Down 20, I'm going to go down by times 10 times 10, which is 100, 30, 40. So if I go down, subtract 30 decibels, I'm going down times 10 3 times. And this would be 4 times. So 10 to the fourth, 10 4 times is 1, 2, 3, 4. Right? I think I did that right. No, wait. So 10 times 10 times 10 times 10. I think I got that right now. So if we have a 40 decibel drop in loudness, then yeah, our intensity actually went down by 10,000. So it's reduced by 10,000 times for 40 decibels. If we have a sound reduced by 30 decibels, it is 1,000 times less intense. A sound dropped by 20 decibels would be 100 times less intense. So again, this is just another example of that logarithm. So what I'd like you to be able to do is, if I say, okay, we're going to drop a sound or increase a sound by 45 decibels or 40 decibels, how much is it going to go up by? So that's what I'd like you to be able to do in terms of the intensity and intensity level, the loudness connection. And then I'd also like you to remember this, it's just a useful tool. I mean, it's nothing special about the math. It's not a new concept. It's the same concept as logarithms and intensity level, but it's just a good rule of thumb. So if you double the intensity, your intensity level, your sound, your loudness goes up by +3. All right, and there's an introduction to sounds, intensity, and intensity level and loudness. Good job for watching.